In this video, we will discuss how to tie an apposing knot using half-hitch throws. We will conceptually divide the tying of a half-hitch apposing knot into two parts, the initiating throws and the securing throws. For an apposing knot around tissues that are not under tension, the initiating throws are the first two throws of the knot. The purpose of these first two throws is to tie an initial knot that has the ability to slip. This allows for additional tightening of the initial knot in case the knot loosens during the process of tying. In other words, it allows us to avoid a non-apposing or air knot. Once this initial knot is tied, it should provide adequate stability for subsequent securing throws. These are important for knot security because a knot that can be slipped forwards can also be slipped backwards to become a non-apposing knot. The first throw of the half-hitch apposing knot can be overhand or underhand. The mechanics of tightening the first throw are different from those of subsequent throws. We will describe here a technique to allow you to control the resultant relative lengths of the suture strand ends at the completion of tightening of the first throw. Before we demonstrate this technique, let's first demonstrate the extreme ends of the spectrum that lead to uneven suture strand ends. First, if we hold our left hand as a post during tightening and push the throw down with our right hand, this will result in the strand end held by the left being too long and the strand end pushed down by the right hand being too short, as seen here. If, in contrast, we hold the strand with our right hand tightly and push down the strand held by our left hand with our right hand, this will leave the strand end held by the left too short and the strand end held by the right too long, as seen here. So instead, we want to push the first throw down in such a way that the post strand switches back and forth between the strands held by the right and left hands. To accomplish this, imagine a line perpendicular to the surface of the wooden board emanating from a point midway between the exit sites of the two suture strands from the wooden board. If we hold the suture strand ends in such a way that the site where they cross is positioned along this imaginary line, and apply tension to the strand ends with the left and right hands such that the imaginary line bisects the angles made by the two suture strands as they enter and exit their site of crossing, and tighten the throw in such a way that these relationships are maintained, the process will result in the preservation of the relative lengths of the suture strands during tightening. In other words, as we push down the throw, we want to maintain the site of crossing of the suture strands along this imaginary line, and we want to apply tension to each suture strand end such that the angles between them continue to be bisected by the imaginary line. This requires constant readjustment of the magnitudes and directions of the forces applied to the suture strand ends by the right and left hands during tightening. While we have demonstrated this concept when trying to maintain the suture strand ends at even lengths, this technique can be used to achieve any desired relative lengths of the suture strand ends. Simply adjust the strand ends to the desired lengths, perform the first throw, and then tighten evenly using the angle bisection method described to maintain these desired relative lengths. It is also important to note that we do not cross the strands for this technique. Strand crossing and hand crossing do not affect the security of half-hitch knots. Strands or hands can be crossed when tying half-hitch knots, however, it can make the proper identification of the post strand more challenging, and it does not confer additional security to the knot. Regardless of the specific method used for tightening the first throw, most methods involve the post strand flipping back and forth between the two strands. This is problematic because in order to accomplish our goal of tying an initial knot that can be slipped, we must tie the first two throws on the same post. When using real suture instead of shoelace, it is oftentimes difficult and inefficient to identify which strand is the post strand by visualization alone. So instead, we can perform a maneuver to deliberately force one of our two strands to become the post strand. To perform this maneuver, the tightening of the first throw should be stopped a short distance above where it will be laid against the tissue, or in this demonstration, the wooden board. Stopping about a centimeter above the tissue should be adequate when using suture material. Let's suppose we decide that we will use the strand in our left hand, the black strand, as our post for our initiating throws. If we look closely, we can see that currently the white strand is the post strand, and the black strand is wrapped around it. Again, this is easy to see here with different colored shoelaces, but can be difficult to see when using suture material. To force the black strand to become the post, we will apply a larger force to the black strand that is oriented perpendicular and away from the wooden board, and positioned directly over where the black strand exits the wooden board. Simultaneously, we will hold the white strand parallel to the surface of the wooden board, but apply a force to it that is smaller than the force applied to the black strand and in a direction opposite of it. When we perform these maneuvers, if we watch carefully, we can see the post flip from the white strand to the black strand. Looking closely, we can see that the black strand is now the post strand, and the white strand is wrapped around it. Importantly, even if the black strand had been the post strand at the end of tightening of the first throw, the performance of this maneuver would maintain it as the post strand. To finish the first throw, we must tighten it to the proper location. We could tighten it to one of three sites. The first site is where the white strand exits the wooden board. The second site is between where the black and white strands exit the wooden board. The third site is where the black strand exits the wooden board. It is our goal to maintain a knot that will slip for these first two throws, and in order to accomplish this, our post strand must stay straight, as this is the axis along which the knot can be slipped. To keep the black strand straight, we would need to tighten the throw down to where the black strand exits the wooden board, highlighted in red. When we look closely, we can see that the first throw has been tightened over the site where the black strand exits the wooden board. The black strand is thus maintained in a straight post configuration, allowing for slippage as desired. Now that the first throw has been completed, we will discuss the second throw. A common misconception is that to tie a slip knot, the second throw must be an identical throw with respect to the first throw, or in other words, a granny knot. This is inaccurate, as the ability to slip the knot in a half-hitch throw is dependent on whether a single or alternating posts are used, not whether identical or opposite throws are used. We suggest performing an opposite throw for the second throw, as it will confer slightly more security than an identical throw. As long as the same post is maintained, the knot will still slip easily along the axis of the post strand as desired. Since the first throw of this knot was an underhand throw, we perform an overhand throw to make it an opposite throw. The tightening of the second throw is more straightforward than the first, since the tightened first throw will keep the relative lengths of the suture strands stable. Importantly, the same post must be maintained in order for us to be able to slip the knot. Since the black strand was used as the post for the first throw, it is used as the post again for the second throw, and the white strand is pushed down along it. The last consideration for the second throw is the alignment of the non-post strand. The non-post strand, which is the white strand in this case, exits the knot from above, highlighted in blue. This is the part of the white strand that we pushed down to the wooden board during the tightening of the second throw. The same white strand enters the knot from below, also highlighted in blue. This was the part of the white strand that was pushed down during the first throw. To maintain our ability to slip this knot, it is best to align the top strand directly over the bottom strand, such that the force applied to the top strand is transmitted simultaneously to the bottom strand, and they can be pushed down together as a unit. In this way, they serve as a sort of leash for the knot, which prevents tightening on the top strand from causing the black strand to buckle and lose its linear post configuration. As with the first throw, the knot should be tightened to a location directly over where the black strand exits the wooden board to maintain its post configuration. By performing this series of maneuvers for the first two throws, if the initial knot accidentally becomes a non-apposing or air knot, it can be tightened back down to the surface in the same manner as was described for the second throw, that is, by holding the black strand as a post and aligning the two parts of the white strand during tightening. Now that the first two initiating throws are complete, we move on to the securing throws. For each subsequent throw, we will make the throw opposite to the prior throw. Since the second throw was overhand, we will make our third throw underhand. It should be noted that half-hitch square knots are tied by either performing opposite throws using a single active hand, as demonstrated here, or by performing identical throws but alternating between the right and left hands as the active hand. We recommend performing opposite throws using a single active hand because then the strand ends can be adjusted to optimal relative lengths. If the active hand is alternated with each throw, the strand length will generally be suboptimal for at least one of the two hands. The major difference for our securing throws is that we will now alternate the post strand with each throw. Since the black strand served as the post strand for the first two throws, we will now use the white strand for our post strand. We do this by holding the white strand upright like a post. However, we want to hold it with the least amount of force necessary to keep it in a straight post configuration, because applying too much tension can loosen the initial two throws, leading to a non-apposing or air knot. So it is critical that we hold the white strand with as little force as necessary to keep it straight, and to push the black strand down along the white strand. Once the third throw is in contact with the second throw, greater tension can be applied by the right and left hands to tighten the throw at the level of the knot. For each subsequent throw, we then repeat this pattern by performing an opposite throw from the prior throw and tightening on an alternate post from the prior throw. So for the fourth throw, we perform an overhand throw and tighten it using the black strand as a post. Then for the fifth throw, we perform an underhand throw and tighten it using the white strand as the post. If we look closely at the final knot, we can see the resultant configuration. For the first two throws, the black strand serves as the post, and the white strand wraps around it twice. Then the white strand becomes the post, and the black strand wraps around it. Then the black strand again becomes the post, and so on. Let's now observe the process when using suture material instead of shoelace. To achieve a desired length for the strand held by the right hand, which we will use as the active tying hand, we pull the strand held by the left hand. We then perform an overhand throw and tighten it until a short distance above the wooden board. Note that at the conclusion of this tightening, in contrast to the different colored shoelaces, it is very difficult to tell which strand is the post strand and which is the non-post strand. For this knot, we will plan to start with the strand held by the left hand as the post strand, so we pull up on that strand such that it is held straight above where it exits the wooden board, while simultaneously holding the strand by the right hand such that it is parallel to the surface of the wooden board, and we push that strand down to the wooden board. The first throw is then tightened to the site where the strand held by the left hand exits the wooden board. Note that in this case, after the first throw is tightened, it slips backwards. This is okay because we plan to deliberately make our initial knot one that will slip by using a single post, as this will allow us to slip the initial knot back down to the surface of the wooden board. An underhand throw is then performed and tightened. By holding the strand in our left hand as a post and pushing down the second throw with the right hand such that it is aligned directly above the first throw so that they can be pushed down together as a unit, the knot can be slipped down to the surface, avoiding a non-apposing knot. An overhand throw is then performed and tightened, but now the strand held by the right hand is held as the post, with only enough force used to maintain it as the post strand, because too much force could cause the knot to slip backwards again, or for the strand held by the right hand to become the post strand for the first two throws inadvertently. Once the third throw has been gently tightened down to the level of the second throw, higher levels of tension can be applied by the right and left hands to tighten the throw in place here. An underhand throw is then performed and tightened with the strand held by the left hand as the post, while the strand held by the right hand is pushed down to the wooden board. Finally, one more overhand throw is performed and pushed down by the left hand, while the strand held by the right hand is held up as the post. For demonstration purposes, we have tied a knot with 5 throws here. However, the number of throws needed for any given scenario depends on many factors, which we will not discuss here.